Welcome to McPlum, simple solutions served daily.
You begin by verifying the arrestor is rated for your system voltage and phase count. This ensures correct protection. Once done, de-energize and apply lockout/tagout because any live work risks severe injury. Make sure to mount the arrestor at the service entrance with the shortest possible conductor run. Shorter leads reduce impedance and improve performance. While you position the unit, confirm the enclosure is grounded path-ready and that you have appropriate connectors and an insulated torque wrench to make the first electrical connections securely. You now focus on creating a low-impedance bonding path between the arrestor and the main ground electrode. Use a suitably sized copper conductor per local code. Undersized conductors increase let-through voltage. Make sure connections are tight. Clean metal, apply anti-corrosion paste, and torque lugs to specified values. Once bonded, route the grounding conductor in as straight a run as possible and avoid unnecessary bends or loops because they add inductance. Finally, double-check that the arrestor's line terminals are secured and face-to-ground clearances meet safety requirements. You finish by inspecting every mechanical and electrical connection. Verify torque, clearances, and that protective covers are fitted to prevent accidental contact. Once satisfied, re-energize the system following your safety checklist and watch for abnormal indicators such as humming, heat, or visible leakage. These signal a problem. If something goes wrong, isolate power immediately, retorque and clean connections, and measure ground resistance. Aiming for low values, often below 5 ohms, matters because a poor ground undermines the arrestor's effectiveness and can cause repeat.
Thanks for watching. Stay juicy and subscribe.